Welcome, and thank you for taking the time to view our final presentation. This is the culmination of 2 semesters worth of work, and we are proud to finally share the outcome with you. My name is Michael Burke, and the other voices that will be accompanying mine are that of Joseph Meredith, Jonathan Buchanan, Alexander Schott, Logan Schick, and James Johnson. We are Team 3D Feeling, JIC 9328, and we are happy to present you our project. Without further ado, let's take a look at what this presentation will cover. For the first semester of this class, we spent a great deal of time centering our focus, developing a mission, and designing an ideal user experience. To begin, we will cover that design and mission briefly before discussing who might actually be interested in what we have made. Next, we will discuss the technical implementation of our project, which is mainly divided into the website, natural language processing, and object generation code. My teammates will delve into the details of what subproblems these categories contain, how we address those problems with various tools and technologies, and how they all integrate to form the finished project. Finally, we will demo that result and show how it all works from a user's perspective. We will also highlight important features that secure and facilitate the user's experience. Before we begin on how the project was actually created, I want to clarify why we have devoted 2 semesters of our time to developing it. We have built the 3D Feeling language-to-object converter to give users the ability to quantify emotions and give them physical form. Over time, people have come up with methods of displaying their emotion through mediums such as emoticons, but nothing, to our knowledge, attempts to quantify the emotions of a large body of text. So, for our mission, we want to pioneer an open source initiative to be able to view emotions as shapes and inspire people to connect technology with art. In order to make this as easily accessible as possible, we have written open source code as well as realized the project through a website that anyone can access, as you will see later in the presentation. As for who will be using this, I'll let Joseph tell you about our client and potential user base.
Our primary user is Dr. Gollihue, as this project is part of one of her research projects. Our secondary users are 3D printing hobbyists and linguistic researchers, or anyone who would be interested in visualization of emotions. Our website is designed to be able to be used by anyone, even people who have no experience with 3D printing or natural language processing. We have links to resources that would help users understand how to use the output file if they don't have experience, and the simple UI of the website makes it very easy to navigate. We also have a page explaining how everything works if the users are interested to learn more. When performing user research, we interviewed fellow students who would be likely to use this site for information on how they perceive emotions so that we could use this data when creating our shaping algorithm. You can see some examples of the results of these interviews on this slide.
On the main page of our website, the user is presented with a navigation bar, a short description, and 2 alternative text input methods. In addition to facilitating moving around the site, the navbar also has a theme button that allows you to switch between light and dark modes. After typing or uploading a text document, the user can then click Submit, where they'll sit on a short spinner while our backend analyzes their input. Once the server is done, the website displays the results. In the main part of the page, there's an interactive render of the shape that was generated from their text, along with a recommendation of what color we think might suit the shape. In the top right, there's a graph of the raw output of our sentiment analysis algorithm for users more interested in the natural language processing or technical side of things. Below that, the text that the user entered is displayed for reference, and so they can verify their file contained what they thought it did. Finally, below the model are the options to download an STL version of the shape and a link to the details page. On the details page, there is simply more information about stuff like the problem we're trying to solve, a short description of how our natural language processing works, and an explanation of how we get from raw numbers to an abstract artistic shape.
Part of our project goal is to take objective measurements of text. Having good measurements to use as a base for our shaping process allows the shapes to be more meaningful. We find these measurements by applying techniques from natural language processing to gain statistical measures of how much emotion might be stored in the text. We are specifically measuring 3 variables: valence, arousal, and dominance. Valence, sometimes known as pleasure, describes whether an emotion is positive or negative. For example, a happy emotion would have high valence, but sad emotions have low valence. Arousal is a measure of how strong an emotion is. For example, anger is a stronger emotion compared to sadness. Finally, dominance is a measure of how much control an emotion has on its experiencer. In order to measure these values from user text, we built classifiers that utilize machine learning and natural language processing techniques to predict emotions in text. In our classification process, we divide the text we receive into a series of sentences and then classify each sentence for valence, arousal, and dominance value. Next, we take these values for each sentence and construct a 3D shape.
Over the past few months, we've been iterating on our object generation methodology, with the goal of creating shapes in a way that's deterministic and that produces distinct objects. The task of generating a shape that represents the emotional value of text is a difficult one because there's no correct answer, but we feel we were able to end up on at least an interesting one. Early on, we decided to use a wave function with the valence, arousal, and dominance values as the input, and use those waves to create a topography of a baseline shape. We tried applying this to both a rectangular base and a cylindrical base, but eventually decided that these objects ended up looking too similar to each other. So in our final iteration, we decided to also have the base shape be determined by the valence, arousal, and dominance values to make sure each object would look less uniform.
This is the current version of 3dfeeling.ga. We have SSL implemented. We've added the new logo in the upper left-hand corner. We have a optional dark mode with a default light mode. In this text box, you can type in text to be analyzed or copy and paste. And here you can upload a file to be analyzed, which we will do right now, and then submit that. And after a short wait, we get the results. Here you can see the actual VAD values that were found by the model in the backend. And here's just a text box with the text that you submitted. And then this is a preview of the model where you can see the model in the suggested color in which we print, which is also noted here in hex. And then if you like the model, you can click download to download the STL file and potentially print out the object if you so desire. And lastly, we have a details page, which goes into more depth about how the website was created, such as the front end and the back end, how the NLP was created and what goes into that, as well as how the object generation is done. In the end, we were able to complete all of our MVP features, as well as the stretch features of recommending a color for the object to be printed in, as well as a dark theme which the user can switch to in the nav bar. Feel free to go visit the website on your own and analyze some text and look at some cool shapes. And finally, thank you for watching our presentation.